Hello and welcome to Hemlock Explains. In this video, I will be talking about the OSI model. And I'm going to explain what it is and how you could use it. So what is the OSI model? The OSI model is, as is in the name, a model. And a model is basically a framework that you can use to understand something. And so why do we need this? Why do we need an OSI model? So imagine if you have a customer and a customer says, why isn't your website working? And let's say that you have a website and it just shows pictures of cats. So how could you respond? There are two options here. The first option is you could say, let me start by examining every one of the billions of ones and zeros that have gone in and out of your network in the past day, and let me see, and let me look at that level for the problem. Or you could look at every bit of ones and zeros that have gone in and out of your cat server. This obviously isn't a good solution. Or you could say, let me start investigating this by finding out which of the 7 layers, these 7 layers, this is referring to the OSI model, might be acting up. And so basically it's kind of a shorthand for understanding how traffic goes from one computer to another computer. And it allows you to think of it in terms of layers so that you can kind of troubleshoot and figure out what's going on. So let's look at this next slide. So these 7 layers right here, this is actually the OSI model. The OSI model is divided into 7 layers. And so let's go back to that example where we have a person and they're on a laptop and they're trying to connect to your server, and they're going to try to look for a cat video that your server serves up. So first I'm going to explain this in a really high level way, and then we're going to go down and we're going to look at each of these different layers to see exactly what they do. So from a really high level, let's say that our server is over here and has some cat photos on it, and we have the user over here. So if they were to, like, let's say that they enter in and they say, okay, I want to see the picture of the blonde cat. Okay, so the place where they would enter that is in their web browser, which is actually at the application layer. So it would start at the application layer, and then it would go down to the presentation, session layer, transport layer, network layer, data link layer, and then the physical layer. From the physical layer, it goes over some wires, and we'll just say that this is the magic internet cloud. And then it reaches the server on the other side, the server that actually hosts the cat picture. From here, it would actually go in the reverse direction. So it would go from layer 1, 2, 3, 4, 5, 6, 7, up to the application layer on the server, and then it would do something interesting. Once that picture of that blonde cat is found, it would go back down. It would go from the application layer all the way down to the physical layer through this magical internet cloud and back to your computer. So that's kind of the direction of this. That doesn't tell you anything about what these layers actually are, but it kind of tells you the direction of it. It goes down from 7. If you enter something in Chrome, it goes down from 7 to 1, goes to a server, goes up from 1 to 7, and then if it sends you a response, it'll go back down again. And so let's start to look at what these layers actually are. And before I do that, I want to issue a caveat. So the OSI model was made in the 1970s. And to the credit of the people that made this, it's kind of an amazing model because it still applies and it's still used today. Like I said, someone might say, oh, this is a network 2 device or this is a network 3 device, and they're referring to the OSI model or perhaps the TCP model, which came later, but a lot of that was based on the OSI model. But the caveat that I want to issue is that because this came from the 1970s, the people in the 70s, even though they did a great job, they didn't recognize everything that would happen over the internet. And so some of these layers, particularly layers 4 to 6, are a little bit outdated because of this 1970s thing, but we'll talk about that. Okay, so let's start going through these layers one by one. Let's start with the physical layer. And so when you think of the physical layer, this is the ground root layer. You should really think of things like cables or actual, signals traveling over the air via Wi-Fi. So, you see the name here, physical. This is actually the physical medium that your data is traveling. So, okay, so now let's talk about the data link layer. The data link layer is a layer that you should associate with LANs, which is a local access network. So, let's imagine that you had the you had the computer and the server in the exact same room. Or we could even say that, I'm not going to say this is a server. I'm going to say that, imagine that you want to have something routed out onto the internet, and you're connected to a router by cable or Wi-Fi, it doesn't really matter. But the point is that these two devices would know each other's MAC address if you're in the same room. So when you go onto google.com and you search for blonde cat and you hit enter, that traffic goes to your router that's in your house, and it will find your router not by an IP address, but by a MAC address. And a MAC address is just an address that identifies a physical machine, a specific machine. And every machine in the world has a MAC address, and it just identifies that MAC address. But what if you wanted to have traffic that went from a computer in New York to a computer in California? This would be called a wide access network, and you would need, instead of MAC addressing, IP addressing. So the thing with IP addressing is, with an IP address, it's a logical address, and the network layer has specific things involved that are built into it that help computers find other computers over a really wide network. There are routing protocols and things like that in here. Whereas the data link layer, it might do something just, shout out, hey, everyone, return your MAC address to me. And so that's not actually a good protocol if you're doing something from New York to California. If you're doing something from New York to California and you say, hey, everyone from New York, I just want to get every single MAC address in the world and then find the correct one, you would have to have every single computer in the world respond to you. And so that's why the data link layer can't suffice for wide access networks, and that's why we need the networking layer. And so now here we're getting into the 3 layers that I was saying kind of maybe don't make sense in terms of today's world. And I think we group a lot of these together, but we can still break down what's inside of these conceptually. And so let's talk about the transport layer first. And so the transport layer handles transport, but that's really broad. But one quick word that you can think of if you think of the transport layer is packets. So now imagine that the blonde cat photo that I have here is a million bits long, and you requested that photo. And now when internet traffic is sent over with a TCP connection, your computer will do something called error checking. And so if you now imagine that my server sends you the photo of this blonde cat, and as it's going through, there's some kind of weird radio wave that interferes with some cable on the way to your computer, and something gets messed up. Well, your computer will do error checking and it will know that this photo of the blonde cat isn't correct. But what does it do then? Does it then send a signal and say, okay, I need all of those million bits again? Well, that could become cumbersome. And so basically on the internet, we break things up into packets. And so packets are typically about 1,500 bytes. Or 8 times 1,500 bits, because each byte is 8 bits. And so what the transport layer does is it breaks your traffic down. When you are receiving the picture of the blonde cat, it will, if it's a million bytes, you will have whatever number this is. Oh, excuse me. Divided by 1,500. This is how many packets you would get. And so your traffic would actually be divided into this many packets. And so if there's an error in one of these packets, you would just request that one specific packet rather than the whole thing. And that's kind of what the transport layer does. Okay, now let's talk about the session layer. Okay, so imagine, let's say that my server, it hosts cat pictures, but it hosts cat pictures that you might upload. And so let's say that there are two people. Here's Bob. And here's Tom. And they both type into their browser cat pictures .com/my pics. And I'm not sure this is a real website, so don't go to this website. But so they both enter this, and they're both kind of expecting to see their own pictures. So your server has a place for catpictures.com/mypics, and when Tom enters it, he's expecting to see pictures of his cat, and when Bob enters it, Bob is expecting to see pictures of his cat. And Bob would actually get upset if Tom entered catpictures.com/mypics and saw Bob's pictures, because the pictures are private. And so this is achieved through the session layer. And so the session layer will store information about a specific user. And so it might store cookies on your browser that'll give information about, who am I? And so this information, you can start a session with the server, and the server will remember who you are and what it means when you hit catpictures.com/mypics. What does that mean for you specifically from your browser? And so that's kind of what the session layer does. And so the presentation layer, this is really the layer where the OSI model kind of breaks down and isn't perfect anymore. But it basically presents the information to the application layer. And you can think of this as something that happens at the OS level. And so you have Chrome, and you have, let's say you have Mac OS. And so Mac OS is kind of handling and presenting this information to Google Chrome. And so you can think of that as the presentation layer. Okay, now last but not least, we have the application layer. And the application layer is literally the application. And I know that's vague, but think of something like any application that you would have on your browser, like Google Chrome or Safari or Microsoft Edge, or think about Microsoft Outlook. And so this is actually the layer that is presenting the information to you. And so now that we kind of have this understanding, let's think back to this blonde cat example. So you're on my website and you go to catpictures.com/mypics. So it starts in the Chrome browser, and that's the application layer. And then the Chrome browser we're going to group all these layers together. So it will do something where it makes the information that you entered from the application layer make sense to your operating system. And then it will, embed something so that if you had a previous session with my server, it will know who you are. And then the transport layer will break down this traffic that you're sending into 1500 byte packets. From there, this traffic will be encapsulated into a network layer that will explain what IP address it needs to go to, and then it will be broken down into a data link layer. And this might explain, okay, how do I find the router, that first initial router that I need to send it to with the MAC address? And then it will go down to the physical layer, which will be just like the cables or the Wi-Fi or whatever it goes over. And so then once it goes over the internet, when it gets to the final destination, it will, or even while it's traveling through to the final destination, imagine it gets to the final router, then it will be on the wire, and it'll be on the router, and then it will be on the wire headed to the server, and that will use the MAC address, and it got there because it knew the IP address. And then it will use all these things to, determine how many bytes are in each packet. It will determine whose session it is. And then whatever application, this might be some web server application, will handle this, will send back the correct cat picture to you. And the whole thing will be reversed in this purple line. And so if we're to look back at this, why do we need a model? We can actually start looking at these different layers and kind of break it down. Like, okay, first thing to check is maybe the physical layer. Is your computer actually connected to a cable? Now let's look at the data link layer. Can it reach a specific can it reach the router? Then the next thing is the network layer. Do you have the right IP address? You say you can't reach my website, but maybe you're actually just not entering the correct IP address. All these things kind of handle the packets, the size of it, the session. And then, is your Chrome browser working, or is my web server working? And so you can kind of break it down, and you can think of any problem that you could have with networking in terms of these 7 layers. And so that's really what the OSI model is. The OSI model is just a way to kind of think about network traffic, or traffic that computers are sending, and how you can break it down and troubleshoot it. It's a model to help you. And so I hope that's helpful, but that's all I have for the OSI model.